Hello, this is Dr. Mahesh Kalyanshetti, Associate Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. Today we will discuss on earth pressure of soil, where we will focus on the introductory part. The learning outcome will be at the end of this session, the students will be able to describe the earth pressure developed on the retaining structures. Let us try to understand what is the earth pressure. So, earth pressure is a lateral pressure which is exerted by soil mass on the retaining structure, and this particular pressure is due to the self weight of the soil mass and the external forces which are acting on the soil mass. As you can see in this image, a typical retaining wall is shown which is retaining the soil mass at the back side. So, this retainment or this backfill is exerting a pressure on this particular retaining wall, and this particular pressure is not only because of the weight of the soil mass, it is maybe because of the surcharge load which is placed on the embankment or the filling, or the earthquake. Because of the earthquakes also there is a development of the lateral pressure which will be acting on the retaining wall, and also the pressure may be because of the water which is present in the soil mass. These are some earth retaining structures shown. The first one, as we can see here, it is a gravity retaining wall, wherein the gravity wall is constructed to retain the soil mass. Another is a cantilever retaining wall, where it has got a base slab, then the heel portion, toe portion, and the stem, vertical portion is called as a stem, and the soil mass is retained at the back side of this particular vertical wall. Then another type is a counterfort retaining wall, wherein the counterforts are used along the length just to improve its performance. Then next is a buttress retaining wall, wherein the buttresses are used. Then the sheet pile wall. Then you can see the anchored bulkhead. So, these kind of structures are also used to retain the soil mass, and these structures are experiencing the earth pressure. Then the bridge abutment is another example, wherein at the back side the soil mass will exert a pressure on the abutment, and even in the water storage tanks also, the groundwater water storage tanks also, the pressure is exerted on the retaining structure. So, these are some typical structures which are used to retain the soil mass. Some photographs again, just to understand the various types of structures used on the field. So, this is a typical view of the abutment, and at the back side we can see the soil mass is retained, and this soil mass will exert a pressure on the abutment. On the right hand side also we can see the return type of abutment. Here also the filling is in progress. So, this particular soil mass will exert a pressure on this particular abutment wall. So, this is an RE wall used in case of the flyovers. So, this particular RE walls are also resisting the soil pressure. Another view on this side, the panels are been erected, and in between you can see the soil mass is filled, and these panels are subjected to the lateral earth pressure of the soil, which we call it as earth pressure. These are the examples of the sheet pile walls. So, these are also some kind of structures which are resisting the soil mass and subjected to earth pressure. So, there are three types of earth pressure which we come across, so which are been explained here with the help of this particular picture. So, the first one is called as the earth pressure at rest. So, here you can see in such condition the earth pressure, whatever is earth pressure is generated, that we call it as earth pressure at rest. In such cases the earth retaining structures are not allowed to move in a lateral directions. So, therefore, these particular structures experiences this at rest condition. Whereas, in other type of structure on the right hand side we can see on the retaining wall the soil mass is exerting a pressure, and as a result of this there is a slight movement of the retaining wall we expect. So, if the retaining wall is moving away from the backfill, then that particular pressure we call it as an active pressure, and the opposite side, the soil mass, you can see here in the opposite side, the retaining wall is moving towards that backfill. So, this particular pressure we call it as passive pressure. So, a little bit elaboration we will do for the earth pressure at rest condition. So, as I already mentioned in the last slide, that the earth pressure at rest refers to the lateral pressure exerted by the soil on a retaining structure when the structure does not move or deform laterally. So, there is no scope for the lateral movement of the retaining structure. So, under such circumstances, whatever pressure is exerted by the soil, that we call it as earth pressure at rest. So, this condition arises when the wall is rigid and fully restrained. So, the example is the basement wall fixed at both bottom and top. You can see here, this is an abutment where we have an embedment at the bottom, and at the top it has been restrained by the rigid slab. Therefore, this abutment wall is not allowed to move in a lateral direction. So, therefore, it will experience the earth pressure at rest condition. So, key characteristics of the earth pressure at rest is that there is no lateral strain in the soil because no moment is allowed, therefore, no strain is developed in the soil mass. The soil remains in elastic equilibrium, therefore, we never experience any failure or yielding in the soil mass, and the pressure distribution is typically linear with the depth, and these kind of pressures are common in rigid walls, bridge abutments and underground structures. Whereas, if I go for the active earth pressure, so here you can see the active earth pressure is the lateral force exerted by the soil on a retaining structure when the structure moves away from the soil, allowing the soil to expand and mobilize its shear strength. So, you can see here, if I take an example of this retaining wall is now, it is having a freedom to move in a lateral direction. So, it moves away from the soil. So, in such condition, whatever pressure is exerted, that we call it as active earth pressure. So, this condition represents the minimum lateral pressure. So, active earth pressure is a minimum lateral pressure which has been experienced by the retaining structure. The key characteristics of this active earth pressure is, again, it occurs when the wall tilts or translate outward. Outward means away from the backfill, then only this particular earth pressure gets initiated. Then the soil reaches a state of plastic equilibrium on the verge of shear failure. So, because of the lateral movement of the retaining wall, the soil mass also will experience the lateral deformation and it will attain the plastic equilibrium. The pressure distribution is typically triangular, increasing with the depth, and this kind of earth pressure are common in flexible retaining walls such as cantilever wall or sheet pile. So, this is about the active earth pressure, whereas on the opposite side simultaneously the passive pressure is generated when the wall is moving towards the backfill. So, that has been explained here. So, the passive earth pressure is the lateral resistance offered by the soil when the retaining structure moves towards the soil and compressing it. So, the movement of the retaining wall is such that it moves towards the backfill and it compresses the soil mass. So, under such circumstances, whatever pressure is experienced by the retaining wall, that we call it as passive earth pressure. So, this condition represents the maximum lateral earth pressure. So, under such conditions, we always get the maximum lateral pressure. The soil can mobilize before it fails. Key characteristics, again, it occurs when the wall pushes into the soil and causing horizontal compression. The soil mobilizes its full shear strength in resistance, and this kind of earth pressure is quite common in sheet pile walls, bridge abutments and deep foundations where the retaining structures are likely to have the moment towards the backfill. It likes a compression of the soil mass. Then let us go to the next concept, which is called coefficient of lateral earth pressure. So once we as we understood the three types of earth pressure, that is earth pressure at rest, active earth pressure and passive earth pressure. Next is to define the coefficient of lateral earth pressure, which is a fundamental concept in geotechnical engineering that quantifies the ratio of horizontal lateral stress to vertical stress in the soil mass. So with the help of this figure, I have made an attempt to describe this coefficient of lateral earth pressure. So at any soil element, it's an exaggerated soil element which is shown here. There we see that there are two pressures present. One is in a horizontal direction, another is in a vertical direction. So the ratio between these horizontal pressure and vertical pressure is called as coefficient of lateral earth pressure. So which is indicated by capital K. It's a universal symbol used to represent the coefficient of earth pressure, which is given as sigma h upon sigma v. So lateral earth pressures have the nomenclature depending upon the types of pressure. So if the condition is of active earth pressure, then that is called as active earth pressure coefficient. It means it is the ratio of horizontal and vertical principal effective stresses when the retaining wall moves away from the retaining wall. And in case of the passive situation, whatever is the ratio of the horizontal stress to vertical stress, that we call it as passive earth pressure. And last one is the coefficient of earth pressure at rest. It is the ratio of horizontal and vertical stresses when the retaining wall doesn't move at all. So depending upon the movement of the wall, we have these particular coefficients designated: when the wall moves away from the backfill, when the wall moves towards the backfill, and when wall doesn't move. These are the references used for this particular presentation. Thank you.